All yours.
All right, thank you, Nimrod. Thanks everybody for coming. Like what Nimrod said, I really want to thank you guys because it's such a beautiful day outside. I know you've taken extra effort to come here. So regard that and give out this helicopter to somebody here, okay? The only thing is, you have to put your name and then randomly pick a name from here, okay? Hopefully that's good enough, okay? Fill in your first name, last name. If you don't care about helicopter, you're going to have to put it. It's up to you guys.
And if you didn't bring a pen, you can't solve
Yeah,
it.
put your cancel camera out as well. And I'm going to give out a few t-shirts also randomly for somebody who asks me the tough questions, but something that I can answer. My name is Raghavan, Srinivas, we go by Rags. Can everybody hear me in the back?
Yes.
This mic is supposed to be working, and my problem usually is that it's not that people can't hear me, it's like people can't hear me after a while. You get a little loud, so just ask me to tone it down if you think I'm going too fast or too loud or something like that, okay? I work as a developer advocate at Couchbase, and Couchbase is the name of the company, name of the product. It was an amalgamation of CouchDB and Memcached. Memcached is used by a lot of customers. CouchDB is more recent. What is happening is if you think about Memcached, it's really more of a key value pair, and we'll talk about that in a second. But CouchDB is more of a document store, and we have kind of brought those two together, and that's what it's called Couchbase. So that's why I corrected you, because it's not really CouchDB, but it's Couchbase. But there are some features that are being added from CouchDB to Couchbase. Again, feel free to stop me anytime. If it seems like we are rat-holing, I'll try to kind of move on. Okay, but I think there is a lot of value in questions. Okay, so the goal for today is to kind of get started on programming with Couchbase and Java. Okay, to learn about some of the basic operations, some advanced operations, some asynchronous operations, and so on. Some of our customers use literally thousands of servers, millions of transactions, and so on. You might have heard of Zynga or OpenGPath. They use Memcached and Couchbase, and they were able to scale literally, from like dozens of servers to thousands of servers within a matter of a few weeks, because system administration is very straightforward. Unfortunately, my demos are actually running on Amazon EC2, but I'm not able to access them because I think IEI is blocking off access to a particular port. So Nimrod and I were talking, maybe we could run a cable to wherever the Amazon server is, but still, most of these I'll do some demos of the local also. But there are certain other demos which I cannot do, which is running on EC2. Unfortunately, that's the situation.
I think there's a coffee shop, right?
Coffee shop?
I think there's a coffee shop line of sight out the window from me.
I'll try that. Okay, I'll try to piggyback on there if I want and see if that works. That may be a good idea. Yeah, I'll try that. I did that once, actually. And look, but I could, any problem with the demo, I could blame it on the so that makes it easy. We will look at some of the secondary indexing feature, and this is also something that has come in through CouchDB. And the last thing we're going to look at is how do we enhance an application using views and queries. Okay? And we'll look into all this. So before I get started, how many of you already use CouchDB? Anybody using CouchDB? Anybody using Couchbase today? Yeah? Okay. Anybody using kind of the NoSQL family? Okay. What do you use?
Mongo.
Mongo. Okay. Anybody else? Hadoop or Bigtable? Bigtable. Okay.
Cassandra.
Cassandra. Okay.
Elasticsearch.
Elasticsearch. Okay. Elasticsearch. All right. So this talk is primarily about Couchbase. I will talk a little bit about NoSQL. What I've seen in most of my talks is that a lot of developers are struggling to understand what is NoSQL. It's not a replacement for databases by any means. Okay, relational databases are going to be around, it's been around for 40 years. Normalization, all those, still makes sense. It's not going to go away overnight. But at the same time, there are plenty of applications that can benefit from not, relaxing the rules for normalization, if you will, and gaining performance and simplicity. And that's really the goal of most of the NoSQL databases. A little bit about myself. I've worked with Sun before. I've spoken at several conferences. And let's see, I believe in this philosophy. I'm not quite sure what it means, but better to have an unanswered question than an unquestioned answer. Okay. And what I think it means is that if there are more questions towards the end of the talk, I've achieved my goal. Okay. So I'm not going to claim to have a lot of answers, especially for those of you who are the power users, the standard users, the nobody users, or whatever. Okay. But at the same time, the goal is to provoke some thoughts and hopefully I'll get a few questions and I'll give out some t-shirts, like I said, based on the question. Okay. So the agenda is, again, to get started and asynchronous and advanced operations. We're going back. Okay. So how many of you think, what NoSQL is? This is kind of my tongue-in-cheek. But how things happen, right? Now, this is kind of how I have a feeling that's how it kind of happens. But really, there are several different. If you want to see the copy, again, I didn't do that. I'm not creating that. But detailed book is a kind of practice, and especially on NoSQL, I think it makes a lot of sense. It's short for not only SQL. I note here that it's not really replacing SQL, okay? Not really a single class of database like the relational databases. It really encompasses a number of different types of databases, if you will. But generally referred to as a non-relational database. No rigid schema. No need to do auto tables. Your application does not have to be, mirrored in the tables and vice versa. You can evolve your application as the schema evolves, and so on. So often schema-less is probably a very strong term. It's really flexible schema. The key constraints, not too many key constraints. But still there are relationships, there are primary keys and foreign keys and all that. You still have to deal with that, right? But it's going to be a little bit different. No long-lived transactions, and really no concept of a child, which kind of makes a few people shudder, right? So if you have to do a child, you may have to do it. You have to implement it yourself. And it's pretty straightforward actually to do it in Couchbase. You essentially define two views, one the outer view and the inner view, and you kind of go from there to there. And we'll see some examples as well. And generally, they're very, very well suited for global languages. Any of you heard of this theorem before? For those of you who want to use NoSQL, those who haven't used NoSQL, very new to NoSQL, the CAT theorem of Lewis conjecture, basically talks about consistency, availability, and tolerance. And what it says is that you can have only two properties at the same time. So in other words, you have to give up on one of them at any point. Okay, so take any database, any distributed system, you generally have to give up one of those. Okay? So some of them give up on consistency and talk about eventual consistency, right? Some of them talk about not being available all the time. And Couchbase is one of them. It doesn't mean that it's not going to be available at all. But if you are writing to a particular server and if that particular node is down, you may not, you may have to exponentially back off and then try to write it. And again, when I say you, it doesn't mean that you as an application, the Couchbase client library is partition tolerance means that the system works well across multiple partitions. Generally, the NoSQL databases, they are really about partition tolerance, meaning they have multiple systems anyway. It's a distributed system, and they give up either the consistency or the availability. Okay. obviously, consistency and availability, consistency and partition tolerance, or availability and partition tolerance. So you have different combinations of this, right? Consistency and availability, the traditional database is, it's not so good on the partition tolerance, although that's not true anymore. Even they are evolving into more of a partition tolerant model as well. Okay. Consistency and partition tolerance is, Couchbase is one of them. There are other examples there as well. Availability and partition tolerance is another system. And another taxonomy that a lot of people talk about is there are XML databases, there are tabular databases. HBase and Bigtable are good examples. I think one of you is using Bigtable. Key value pairs, Couchbase, before it added views and before it added JSON, was really just a simple key value pair. Okay. There's Redis, VR, Cassandra, MongoDB, a lot of them are in that category. Object databases, there are graph-oriented databases, and then there's document store, which is Couchbase Server, Dorado, CouchDB, and MongoDB. And we'll see what these document stores are in a moment. Okay? Just a very loose taxonomy of the entire class of NoSQL databases. Okay? This Cassandra mentioned that, again, it's a key value pair. And generally, how each of them differentiate amongst each other is, again, going back to consistency, availability, and partition tolerance, and also how easy it is to set up the system, how easy it is to add nodes, how easy it is to subtract nodes, and so on. Okay. Like I said before, I'm not going to go too deep into this. How many of you have seen this before you saw this slide? I've heard of this 8 fallacies. Basically, there are 8 fallacies in distributed computing. I think it was enunciated by an engineer in Sun by the name of Peter Deutsch. He came up with 7, and then James Gosling added the last one, which is the network is homogeneous. Okay, that's far from true. Right? Of course, using Java, you can make the network seem homogeneous, but not necessarily. Right? But essentially, what this means is that when you're programming in distributed systems, a lot of people tend to assume that the bandwidth is infinite, or that the topology never ever changes, or if it does, it's a once in a lifetime operation and you can deal with it. But that's far from being true. The topology is going to change quite a bit. There are multiple administrators. The transport cost is never 0. And a lot of the frameworks try to hide this, under the wraps. And sometimes they do a good job, but a lot of times it's hard to do that because, given the nature of the distributed computing. So just keep this in the back of the mind because all of this will kind of lead into the discussion that I'm getting into. So we've all designed applications. We start off with this monolithic application, certainly spreads like wildfire, like OMG Pop, from 8,000 users to 800 million users, whatever. I don't know how many users they have, but then now all of a sudden you have to deal with that many number of users, right? So typically on the web tier, it's very easy to scale the web tier. You just add more front-end servers, you put a load balancer in the front and you're ready to go, right? Very easy to do that. Typically what happens on the data tier is that, you go to Oracle and call them and tell them, 800 users to 800 million users, what am I going to do, right? And the first thing the Oracle, anybody works for Oracle? I used to work for Sun but essentially what they're going to ask you is, pay a little bit more licensing fee and we'll give you a bigger system. And I think it's going to work fine for a few weeks. Now, what's going to happen after that? How long can it keep going up, right? And there is a limit to that. And also the fact that, when you keep going up, there are certain investments that you essentially have to throw it away. It's not easy to, to reinstall the software that you have already installed and so on, okay? So the answer is, you cannot really keep scaling up. Okay? So what you can do instead is I can do my own sharding algorithm. Okay? So what this means is keys A to L, is going to be served by server 1. Keys M through Z is going to be served by server 2. Right? Now you have some not only distribution, you have some redundancy. So if you want to deal with some of the keys, and let's say the server goes down, you may have some replica on the other one, and kind of deal with that, right? So one is in Seattle, the other one is in Miami or something like that. Let's take an example. Now the problem is what happens when the third server pops up in Kansas City, right? Your sharding algorithm has to change. It has to adapt, to the network topology change. So it's very expensive for an application program to be able to do this sharding algorithm, themselves. For an application programmer to be doing this sharding, and doesn't really perform at web scale. So the goal behind many of the NoSQL databases, Couchbase including, is to take the bonus of this, this sharding algorithm and let the framework kind of do that. And the client library is providing with APIs. Thank you. Anybody else interested in the topic? Oh. Yeah, you can, if you put your name twice, there will be a better chance. Okay. So essentially, I think I've beaten that to death. What the graph at the bottom shows is that you have the system cost in I think orange color. Is that right? And the other one is blue. Yeah. So which talks about application response time. Okay. So as the number of users grow, you'll see that application response time gets a wall, right? The performance is really, at some point it really gets really bad. Your cost is also going up. Because really you're paying more to Oracle, you're paying, for reinstalling your system software, your application software and all that, you're paying overtime to your system administrators to change the network topology and all that. So can we somehow take this exponential curve and flatten it out, right? And that is really the idea behind adding, scaling horizontally than scaling vertically. Okay, that's the idea behind most of the NoSQL databases. And now certainly what happens with your exponential curve is that it kind of becomes somewhat linear. Okay, that's the idea. Okay, so don't scale up, scale across. That's the simple message. Okay. So what is Couchbase? It's basically open source Apache 2.0 license. Commercial support is provided by Couchbase. Okay, there is a free community edition for developers. There's really no licensing, and you can use it today. You can download it. It's available on pretty much any system that you want. Okay, you can install it on your laptop. It's not really very resource heavy. Doesn't take more than 5 to 10 minutes to install. Okay. Enterprise edition is free for 2 nodes, but there is a requirement that you buy the support license for more than 2. Okay. It can be administered via the web console, or you can use the REST API. Again, we'll look into that in a little bit. It's available for Windows, Linux, and Mac. Mac is mainly for development right now. Okay. Most of our installations are generally in the Linux space. Okay. It's written in C and C++, with more of them being in C and C++ than Erlang. It started off with Erlang, but now it's more of C and C++. For a person who uses CouchDB here, there is more and more of the CouchDB features, including using CouchDB as a vector space. Question?
I'm assuming that for Windows, Linux, and Mac that you are x86 only.
Yes. Yeah. So AMD, what else?
No, I'm talking about the old Macs.
Yeah, old Macs. Yeah, I don't think it was. Actually, we don't even have something for the 32-bit Macs. So yeah, it's mainly with 64. So the simplest way of looking at this is it's a key value pair, and you can also store a document, and I'll talk about that in a little bit. I've used using standard hash table operations. Keys are distributed evenly, and there is a constant time access to access the keys. Okay. There is a concept of what is referred to as a bucket, and there is a concept of what is referred to as a B bucket. That's a little confusing to somebody who's very new, but think about it in terms of like inodes and files. Files are what users deal with, which is really the bucket, and inodes are kind of the B buckets. Which is really used by the infrastructure. Your key is assigned to a B bucket, but the B bucket could be on really any node, and you don't really care about that. That's really the responsibility of the client libraries to handle. Okay. So with the document store itself, all items are stored as JSON documents. If you don't store it as JSON, it's just like a binary blob. Okay, and I'll talk about that in a little bit. And there are secondary indexes which are stored as B trees. And again, with B trees, you can achieve pretty good speeds. And the secondary indexes also are optimized in such a way that it's re-indexed only when necessary, and it's re-indexed only when it's accessed. Okay, it's not re-indexed all the time. Just because you do an insert or something like that, and it only re-indexes the appropriate queries. And there are certain other optimizations that you can achieve as well. Okay, and we'll talk about that later. So the main goal is simple, fast, and elastic. Okay, that's really the goal for Couchbase, and we take it pretty seriously. Okay. The architecture-wise, there is a data manager and there is a cluster manager. Okay, it provides support for the memcached protocol. Okay, and this is a complicated protocol. If you want to implement it yourself, you can do that as well. And I think there are a few implementations of that. And then there is a cluster manager. As you may expect, the cluster manager kind of deals with heartbeat, process monitor, and so on. Okay, and you can interact with the cluster using the REST management of the web UI. In fact, our web console, when you point it to port 8091, which is the port that's being blocked off here in REI, right? What it does is it uses the REST underneath in the wraps. Okay, so the web console connects to the REST port and then extracts all the information it wants from there. The data manager uses a SQL-like engine for storing the keys. Okay, and I think I attended a talk recently at Jesuit, which was in Zurich, and this person from IBM was talking about, I think the developers, compilers, the tools have all kind of gotten really sophisticated when it comes to multi-core, right? So multi-core is not a major challenge anymore. I mean, there are still some challenges there, but the challenges now have kind of shifted to SSD, disk, memory, and multiple levels of memory and so on. And the idea behind the persistence layer is to shield all these memory details from the developer and let the infrastructure kind of worry about it. Okay? Any questions? Okay.
What was the rationale for not going with the standard HTTP port?
Because it uses a different protocol, right? HTTP really.
So it's not really using HTTP.
No, I mean, you go HTTP, but it supports the memcached.
I'm talking about.
Oh, yeah. I mean, I'm not quite sure. I guess you could make a case for that. But this is really not Couchbase Server is not really a web server per se. That's the first thing, right? This is really only for the admin console.
I've never heard of anybody offering a RESTful web API that doesn't use the standard transport ports on the set because of the people blocking it.
No, that's not true. Because even if you look at Tomcat and all that, right? The admin console is on a different port. Usually it's not an 8080, right? It's a something like that.
Probably this front end of this just in the app.
Right.
I'm sure you can configure it somewhere.
Yeah, I mean, you can definitely configure it. Exactly. Yeah, if you wanted, you can configure it to any port.
But like if it was defaulting to 80 on Linux, you'd have to start it as root, right?
Yeah.
So,
Yeah, exactly. 8080. Yeah, correct. So definitely possible. Okay. moving on. So this is kind of the workflow of, think of it as a key value pair right now. Okay, let's worry about JSON in a moment. Okay, but essentially what I do is when I set the value of a key, it goes to a particular server. One of the key things about Couchbase, and this is a differentiated thing from the other NoSQL databases, is that there is no such concept as a master slave. Okay, it's all everything is equal. Okay, which makes it kind of interesting. Okay, since if you have a master and slave, then you get into all kinds of other issues. Okay, but since all nodes are created equal, essentially what happens is when I write to this particular node and I specify a replication factor, which I can specify. It can be anywhere from 1 to 3, meaning I want 1 replica to 3 replicas. So not just the key, but I can store it in 3 different nodes, right? Couchbase replication key value pair, and it really stores the hotkeys in memory and persists it to disk. All of this happens behind the scenes. I don't really need to worry about any of those. Okay. If you want to realize, if you want to find out if it really persisted to disk, there are some APIs that are available. But really, a lot of times the application program doesn't even care. Yeah.
So how are you handling the simultaneous update in different nodes?
Yeah. So essentially, it's the onus of the application program. Really. Okay. We'll talk about that. There's optimistic concurrency and there's pessimistic concurrency. One is you can grab a log and you can deal with it, right? Or there is something called as optimistic concurrency where you just go ahead and let it happen. Okay, and when there is a collision, you may have to do something after that.
But even with optimistic locking, you can end up in a distributed model where you have 2 people that updated at the same time.
Yes.
It's the same number of different updates.
Right, and essentially what the client libraries do is they take care of this because they know how to map it to a bucket. Okay, and at that point it's atomic. Okay, so that's not a problem. The client libraries will handle that. But you're right. There will be 2 clients, which may be accessing the same key value pair. Yeah.
So is there the 2 systems that are highlighted there? Are those symmetrical, or is one of them like a client system and then the others are server systems?
So let me try to understand your question. So those different servers, are they symmetrical?
Yeah. So the server that's next to the number 2, is that part of the systems that are storing the data nodes? Or is that a separate system that has like Couchbase clients?
Yeah, actually, I don't really know why that's in there, but essentially, that's think about that as just the client library. Okay, so that's really more of a software component than anything else. Okay, and this is really the Couchbase cluster itself.
So that the client somehow knows about multiple.
Correct. Yes, it knows about the multiple nodes. It knows which key goes to which B bucket. Which B bucket is where, and then appropriately writes it to that particular server, and then it's replicated, depending on the application package.
Yeah. So when you add and remove nodes at runtime, how does the rebalancing work?
Yeah. So that's a good point, and maybe I should give you a T-shirt on that. What size do you want? What size do you want? Large. No, you can come with it. So the question was, I forgot the question.
Yeah, the rebalance.
Oh, rebalance. Okay. So essentially, it's not an automatic rebalance. I think that was the point he was trying to make. So there is a button that you have to hit when you add a node, and not just one node. You can add thousands of nodes, and then just hit one rebalance, and you're ready to go. Okay. And then what happens is, keys kind of get redistributed, and more or less there will be an even distribution of keys across all these different servers. And again, unfortunately, I can't show that demo today, because I have no access to EC2. But maybe I'll try that. Going to the cafeteria network. Yeah, question. Yeah. So once you do the rebalance, the client library is notified that a particular node got added and subtracted. Okay? It will, exactly, yeah. Use, Sonnet for that. And the client library is So how many of us have used hash APIs, hash table, hash map, something very simple. The idea is that very simple APIs, get, set, and so on, add, replace. But the problem with the hash APIs is that there is really no persistence, and really does not work on multiple nodes, right? And what happens when your network topology changes and all that? And this is perhaps an oversimplified view of Couchbase, is that it's a distributed hash table, but really a little bit more than that, right? It's really much more than that, because what you do is, if you put in JSON, right, you can add meaning to your data. So if you want all the coffee shops in Seattle, right, then you can do. I gave the coffee shop as an example. Just ironic that I talk about coffee shops in Seattle. And essentially, what you're going to do is you're going to look through the zip code or whatever. You index based on the zip code. You collect all the coffee shops in Seattle and present it back. Okay, which is typically not a key value pair kind of use case, right? A key value pair is more like give me the user details associated with the user ID, give me the item details associated with the item ID, right, and so on. But in this particular case, what I'm doing is I'm kind of making a sweep. Give me the count of all the coffee shops in the Seattle area. I can do that. Pretty straightforward to define this. Yes.
So is the key one of the fields in JSON, or key is a separate piece of data?
Yeah, the key is one of the fields, and if those of you are noticing, it also has a type in there. Okay, so basically you're giving a hint as to what type it is. So this is basically a brewery. Okay, and we'll see an example of beers, breweries. Okay, buying beer and brewery, because developers like beer and brewery. So we pick that, and very simple relationship. Beer is brewed in breweries, breweries brew beer, right? Kind of an end-to-end map, and we'll look at some examples of that as well. So what I think you were trying to ask was, is key part of the JSON? Yes, the ID is part of the JSON. Okay, but not only that, I've also qualified my ID. I prefixed it with the type. So that may be useful sometimes when you want to do some range queries. Like for example, if I want to get all the breweries that start with the A and A, B, and C, whatever, right? Then I can say brewery A to brewery C, get me everything. And I can specify that in a view. Okay, and we'll see how we can do that. I don't know if I answered your question.
More examples.
Oh yeah, we'll look at it. Question.
Are you going to talk about data types?
Yeah, it's basically all JSON. Okay.
But well, in JSON we have strings and numbers and booleans, but like dates, you have a date in there, so.
Right. I mean, you could have pretty much anything. As long as it's JSON. This date, right? This is what you're talking about.
Yeah. So how does Couchbase know that this is a date?
Yeah, it's basically whatever JSON thinks it is. That's kind of how it works. So if you want to kind of start on time, that's probably what you're looking at, right? So essentially, what you have to do is you have to make sure that it started on time, right? And actually, I have an example here where you can chat. We have a chat example where you can display your messages based on when it was done. Okay, whatever. And essentially, you can look through the messages. You can look through the last 2 seconds, last 20 seconds, and there are some examples of that. Okay.
But so this is just based on treating the date as a string and sorting, or is there a special?
No, as a string and sorting. Yeah, unfortunately, that's the way. Okay. So if you throw JSON, I think you can add meaning to your data, but otherwise it's just treated like a variable. Okay. Got you? Okay. Instantly, so let's get started. Number of operating systems are supported. I already talked to you about this. A very simple installer. How many of you installed Couchbase? Maybe. Yeah. Very simple to install. I recommend you install the latest Couchbase 2.0 developer preview 4. Okay, if you want to play around with some of this. And really very easy. Once you install it, just point it to host name and you want to be ready. Okay? Pretty straightforward to do this. So going to the client interface, all that I do is I specify the host name, I specify the port. There is some legacy details, like you have to specify /pools, and you have to specify the bucket. You know, there are a number of different buckets. You can have a number of different buckets on an installation. A bucket is kind of the least granular unit where you can allocate resources. Okay, so you can have an authenticated bucket and an unauthenticated bucket. You can allocate RAM to a particular bucket. The namespace is specific to a particular bucket. So I can have rags in default. I can have a rags key in another bucket as well. Okay, so that's so that's a bucket. Okay, you have to specify a bucket name. So what I'm going to do is I'm going to specify the host of the URL. Okay, host of the port. Okay, that's really my URL. Okay, it sends some information back about the bucket, which I don't really care, because the client library handles all that. Okay, and the server also informs the client library about what are all the other nodes participating in the server. Okay, I mean in that cluster. Okay. So now it has the Couchbase client has a map of the different nodes, right? So any network topology changes are automatically reflected in the client library. Okay, so that's the way it works. So if a new node comes online, okay, that is basically notified to the client library map. The client library map is updated, and from an application developer viewpoint, you don't do anything at all. Okay, so when you add a new node, you get a rebalance. That's when the server is ready. Yeah, question.
This is sort of like on Amazon EC2.
Amazon Dynamo, you mean?
Not just on using EC2, because you can't just broadcast stuff because you have the. How are clients, how are nodes discovered? How does the client know which nodes are there?
So essentially what happens is, each server keeps track of, like, you remember this, the cluster manager, right? It knows what other neighboring nodes are there, right? And that is pushed to the client, okay? So when you add a new node and you make it part of the server, that is reflected back to the client, because the client is is connected to the server, to any one of the servers. If you connect it, so all the changes to the network is reflected back in the client.
So how do you bootstrap that?
How do you bootstrap?
How do you get the first connection?
So the first connection is like what I said, right? So essentially the first connection is, you specify the.
Okay,
So that is
you need to know the address.
You have to know the first node. Yeah, and then once you know one, then it's easy to find the rest. Because it's not really, the client will take care of it. Okay.
But so then when you have the second node, how does the second node know that there are other nodes existing already?
So the second node is not technically part of the cluster until you hit the rebalance. Okay. So at that point, the cluster manager for each of those nodes knows that there is another node participating in the cluster. Okay.
So basically, cluster manager is the first node.
It's on every node. The cluster manager is part of every node.
But how does this second node know that it's not alone, that there's another?
Which node is responsible for either the new node or the existing?
So when you add a new node, right, you have to specify what cluster you're going to add it to. Okay.
And that would include these.
And again, when you say what cluster, you're just specifying one node in the cluster. Okay. And that kind of tells you that they're forming a handshake and everything.
So there's no auto-discovery mechanism.
There is no. I mean, you don't need to do anything. It's taken care of it.
You need to configure the address of one other existing machine always. Right?
Yes, you need to configure the server, and then only when you hit the rebalance, only at that point technically it's part of the server. So even though it may be part of the cluster, it's not really part of the cluster until you hit the rebalance. and it's ready.
Yeah, I was asking lots of systems that use some kind of broadcasting mechanism to auto-discover,
Right.
but it doesn't work in all environments. Like if you're hosting on EC2, you can't just broadcast to all of Amazon.
Exactly. So we have taken a more simplified approach where, again, taking OMG Pop and Zynga and those examples. What they do is generally they add like hundreds of nodes and hit the rebalance, and it makes it very easy, right? And if they have to reconfigure the nodes, what they do is they take down, very similar. They add 100, take down 100, so makes it very simple from a system administration viewpoint and also from an administrative viewpoint. Yes.
If you have a network partition, is the client aware that's occurred, right? This splits into two halves, and so it's not really one cluster anymore. Does the client know that and somehow?
Yeah, I mean, as long as the host is reachable, from the client, then it's fair.
The server managers are getting confused, right? They don't know who's on the other side anymore, right? I mean, they've broken between. So these are two different data centers.
Okay.
But the guys on the left and one, the guys on the right, the other. So the servers are all confused about who's in the cluster now, because they can't talk to each other.
They are not
That's
reachable.
the issue.
No, they are not reachable.
Well, no, I'm saying that when you have a partition.
Oh, no, you have
to
to
be resistant.
Okay,
Right? So
okay.
we're saying we have a partition, you can't talk to each other. Does the client resolve that conflict? Is it because it could be talking to each side and knows, oh, this is guys over here.
Yeah, I think what you get into is, we have a feature called cross data center replication. And typically in those cases is where you kind of network partition. So I have a East Coast and a West Coast. And typically what you can do is you can have a cross data center, two data centers and do what is called as a XDR, which is a cross data center replication. And then, anything that's pushed to one node is pushed to the other node. Anything that's pushed from the other node is pushed to this node by using what is called as a changes feed. And all of this happens under the hood. Okay. But I don't think I answered your original question, but maybe we can talk a little bit more about that later. Okay? Yes.
Are you going to cover the case where a node drops out
Yes,
and it
yeah.
comes back?
Exactly. Yeah. So that you're right. It could be a transient failure. If it's a transient failure, what happens is there is a timeout, and that is why it's not available at that time. Okay. If it comes back immediately, then it's going to go back to the. And then there are a limited number of timeouts. So if you hit that number of timeouts, then it's going to rule the server out, and it's going to go and try to find the other node and write. Okay. Yeah.
So this client has a session to the server node, like for management stuff, like this kind of channel back and forth?
Yes.
And then there's a separate connection for when they want to change data on these nodes?
Yeah. So I think you're going a little bit into the internals. Yes. Essentially, we have a number of NIO sockets, to each of these different nodes. Okay. But again, from an application developer perspective, you don't really need to worry about it. The client, the libraries, kind of have those connections ready to go. It puts it in what is referred to as an operation queue. And once the queue is done, then it's going to go and tell the client that it's done and all that. And that's really the onus of the client libraries. Did I answer the question? Sorry. Yeah.
So you can configure that each of your documents is on like 2 or 3 nodes at any time, right? And so if one node drops out, it will automatically do the rebalancing to just make sure that the data is still on 2 nodes and not just one.
Right. So you can specify the replication factor. Okay. If a particular node goes down, right? So like I said, there is a timeout. There are a number of timeouts that have to happen. After that, the node is declared as dead. Until that time, this could be as high as 30 seconds. Which is really a long time, in this kind of applications. Okay. So that particular key may not be available. Okay. And that's really up to your application. Can you tolerate these kind of, and all of these again are tunable. Okay. So you can change these parameters, using the Java client library, using the Couchbase connection manager. But if you can't deal with those timeouts, then you'll have to either tweak the parameters or try something else.
Yeah, but so I mean, after these 30 seconds, does it require a manual rebalance, or is it automatically going to copy the data?
Yeah, so it depends.
So
Right? If I'm reading, right, So the read can be serviced, not a problem, right? But if I'm trying to persist a value, I have to wait for the timeout to happen and for the rebalance to happen for the persistence to. So after a certain time, it's declared as dead. Okay. So if you go back and look at the console, you'll see that one particular server is down. Okay. And nothing is going to go to that rebucket. The rebuckets, if you hit a rebalance, everything is going to get rebalanced. But if you're trying to just access the data, it's going to come. Some of the replicas are going to get promoted, and those replicas are going to be used.
Yeah. The question was more, I'm neither accessing or writing or anything. I specified that I want each piece of data to be available at 2 nodes.
Yes.
If one of the nodes goes down,
yes.
Is Couchbase going to get busy and make sure the data is copied onto a second node? So if the other node goes down as well, the data isn't lost? Or does it wait for you to do a manual rebalance?
So the answer is the replicas happen when you do the set, right? So when you're writing, when you're persisting or whatever, the replica is automatically, we stored let's say, for simplicity, you said 3 replicas, right? So it's going to write not only to the master, I shouldn't be using the term master, but it writes it to one of the buckets, right? To one of the nodes, and then writes it to the remaining 3 nodes as well. All right?
The client does, right?
The client library, so essentially it propagates. It's really, it works in contention with the server as well. Okay. So basically, it writes it to the replicas as well. Okay.
So now one of the nodes goes down. What happens? Is it just happy to have the data just on 2 nodes, or is it going to get busy and copy the data from one of the nodes onto another 3rd node?
Okay. So I think I'm getting your question or your drift right now. Is that what happens when one of the nodes is down and it cannot write the replica, right? Is that kind of
what? When the node goes down, now suddenly there's only 2 replicas instead of 3.
Yes.
Is Couchbase going to correct that automatically and start copying data?
Right. It's not going to worry about replicas. In those cases, it will write 2. Okay. And then when you hit a rebalance, then the replicas are going to get adjusted. So your partition, your cluster is not fully healthy at that point if you know the drift there, right? Because you don't have 2 replicas for that, right? You may have only 1.
Yeah. So it waits for you to do a rebalance.
Correct.
So while you're doing it,
yes, because if you want 2 replicas technically, right, it's not going to happen on the fly until you do the rebalance.
And while you're doing the rebalance, is that like block access to the
No, and that's the beauty of that. Okay. Again, if I'd shown some demos, you can continue sorting the load when the rebalance is happening. Okay. You can do it on the fly. Yes, for both regions. Exactly.
So you could set up some kind of automated thing that detects when the cluster is not healthy, automatically issue a rebalance, right?
You could, yeah. In theory, like I said, anything you can do from the admin console, you can do it from programmatically as well. So you can use the REST interface and you can do the same thing as well. Okay, but there is something called as a rebalance, that hits the all the servers. Okay, yeah.
So, basic question: the replications of any one. The document's routed to server node 1.
Yes.
Its replicants are in that set. There's not replicas behind those other servers.
No.
When you say 2 other replicants, that's server 1 using 2 and 3 as his replicas, right? He duplicates over there in case it goes down.
Correct. Yeah. I don't.
Yeah, I wasn't sure how many nodes we're speaking of in this case.
Yeah, when you say 2 replicas, it means one key plus 2 replicas.
And the replication happens behind it, not because the client sends it 3 times, but because the server sends it to his friends. Is that
Correct.
right?
Yeah.
Related to his question, when these systems were pretty young, one of the problems I heard people complain about was if you have a loaded server and one of your distributed systems goes down.
Yeah.
When it comes, so now you're running it. So you have 5 nodes. You're running at 80%
Yeah.
available resources.
Okay.
When that one comes back online,
Yeah.
not only, you're now running at 70% of, or 60% of available resources because now it's generating load on the other machines
Correct,
while it's
correct.
trying to get back
Yes,
into the
yeah,
game.
yeah.
And then I think some people were saying that then the whole thing would go down. So I'm wondering, that's been a few years. What if anything,
Yeah, I
has
mean,
been done?
like I said, there are some demos where I can show, there are 3 nodes, and then I add 2 nodes, and there is load going on, while it's working, right? Admittedly, we haven't looked at all these different combinations of where, we take down a node, bring that node back up, and then add a few nodes at the same time and all that. I think we have done quite a few of these different combinations, but I'm sure there are exhaustive number of those different combinations, right? But you will see that the load continues to be served. There are about about 1 million keys, and when you do this redistribution, the load continues to be served. We are still doing about 600 operations per second. They're still looking pretty good. Okay. Is there a problem in one of those paths? I mean, it's certainly possible. But I think you're right. In the infancy, there were a lot of issues like this. But I think we have gotten past some of them at least. Okay. Yeah. Let me get there.
Has your organization done any performance measurement in the cases where you have network connections dropping a small percentage of packets and seeing how that affects the performance of the system?
Yeah, we have used different networks and all that, but I can't. I'm not aware of exactly what the results of that, and I'm a little bit removed from that. But if you're interested, we can I can check and get back to you. Yeah.
Some of the other systems I've heard, they don't actually replicate nodes, they replicate key sets. Is that what this system does?
Oh yeah. It only replicates keys. Yeah.
Well, no, my point is that if you remember those 1, 2, 3, 4, one is not replicated.
Oh no. You're not replicating the whole thing because then you're in trouble, right? Yeah. Because what happens is if these 2 go, then you're pretty much dead in the water, right? Whereas at least if you replicate differently, there is a chance that some of the keys can be served for at least some time, right? So only the key sets you write, not the entire that's not a big deal. But I'm glad there are a lot of questions here. I'm kind of in a quantity. I don't know what to do with the t-shirts. There's a lot of questions. So maybe I'll randomly pick names from there. Okay, so how do I connect? Very, very simple. Once you have the jar files, I provide the linked list of the URI. I don't really need to provide all the nodes participating in the cluster. I need to provide one. Okay, the question immediately comes up, what happens if that particular node I'm connecting to goes down? Doesn't matter. Okay, it keeps a connection to all the different nodes which are participating in the cluster, right? And then what happens is I add the list to the URIs. I specify the URIs. I specify the bucket I want to connect to. I specify the password and number. Okay? So it's as simple as that. That kind of makes sense? Okay? Yeah.
Well, you would need a list of URIs, but then we try to real production system because, if the server goes down, you're right, you're fine if you've already connected. But if you haven't connected, then as soon as you try to come in, you will fail, right? So you must presumably, I use a load balancer, or you have to go through the list.
Right. A lot of customers, what they do is they kind of generate this programmatically, and they have a configuration file. They load up the configuration and go through the list. There are ways of getting around it. But for simple development, for simple prototyping, I think this is good enough. Okay. Here it shows an example of connecting to 127.0.0.1, which is the infamous local host or famous local host. Okay. So essentially, I'm connecting to my own server. Okay. Specifying 8091 pools is like a default thing that you have to specify. Okay, it's a legacy thing. Some of the other client libraries like Ruby and .NET too, they don't need that, because they know to go to pools and they use the default bucket and all that. You can just say Couchbase connect, and it's going to connect to the local system, 8091 and all that. There are a little bit smarts in those libraries. Java has been around for a longer time, So, it's a little, you have to specify a little bit more. There are some library dependencies. So if you want to use the Couchbase client library, you just need to use those jar files, but you also have to use some of these jar files in conjunction. Okay? The common codecs which is used for base64 encoding, the JSON which is used for JSON, the native which is used for HTTP comment streaming, HTTP core and HTTP core NIO is used for high performance NIO sockets. And HTTP core is given by HTTP core. Right. So the bottom line is, if you download these Java files, you're pretty much, as a Java programmer, you're ready. Okay? But you don't really need to do all this. If you use Maven, how many of you use Maven? How many of you? Okay. How many of you like Maven? So, yeah, exactly. It's kind of like how many of you use the editor? Everybody uses. So data is stored as a key document. Key is the identifier. It has to be a string without spaces. Okay, so usually you use underscore. And document is a pure byte string. There is a limit on the value of the document that you can store. It's 20 megabytes. If that is a problem, we can talk about that. Okay, it hasn't really been a problem, even for customers. Okay, so each of the the document has to be there's a limit of 20 megabytes. Okay, which means if you're thinking of storing more than 20 megabytes, that can be each. But typically not a problem. Okay. There are a couple of metadata kind of artifacts, if you will. One is the TTL, which is the time to live. Essentially, what this specifies is I want this key to be persisted and to go away after this TTL. Okay? A lot of relational database programmers kind of shudder at this part. What do you mean the data is gone? But you see a value for that, right? Because after a certain amount of time, the data is not really relevant. Okay? There may be a lot of examples like that, right? After I don't know, 31/12, December 31st, 2012, that piece of data is not valuable. So all that I do is I can say TTL until that particular time, okay? And it just doesn't go away.
Because of the end of the world?
Sorry?
Because of the end of the world?
Yeah, because of the end of the world, yeah, whatever it is. Okay.
Whatever your criteria is, you put it in there.
Okay, so essentially what happens is at that point, or you can specify more, because when you're doing some gaming applications, a lot of those data is not really applicable after 30 seconds or whatever that is, right? You can specify that too. So it can either be absolute time or relative. Yeah.
I don't see the optimistic lock version in metadata.
Yes. You check some value. So you went right there.
That's the
Yeah, so basically CAS is the one that's used for optimistic locking, and we'll look at that. Basically CAS stands for a check and set, okay, or compare and swap. So it's basically an atomic operation, and we'll talk about that in a second. Flags are used differently by different client libraries. In the Java client library, it's basically used as a hint for how to serialize it. We use Java serialization by default. But if you want to implement your own serialization, you can override the transporter, and you can do your own serialization. Strongly not recommended. Okay, just use the serialization. Okay, but if you want to, you can do it. Very simple operations and replace set. Very straightforward. Set means you do it no matter what. You set the rags key. Whether it's there or not, you can do it. Okay. Add means only will add it if it's not there, otherwise we give you an error. Replace means only if it's there we do it, otherwise we give you an error. Why you need all the but it's there. Okay. You can specify
I guess the replace supports a version number or optimistic locking.
They don't. They don't. So for those of you who use CouchDB, there is a concept of a version control. Okay. There is a concept of concurrency control and all that, but in Couchbase we don't. Okay, so when you do a set, it's really up to you if you want to do the concurrency control using versioning and so on and so forth. But in CouchDB, what used to happen was each write would generate a different version, and that way you have concurrent writes and reads and all that. We don't do that in Couchbase, but the idea is to get there. This is a feature that came from CouchDB, and that's not implemented.
So right now there's no optimistic locking, or there's another way to...
There is optimistic locking, and we'll talk about that. But you don't have the versioning. Okay. There is no concurrency. I mean, not concurrency anymore. There's no versioning. Okay. Which was there in the version. There are retrieve operations. Get and touch is basically updates the cache. Okay. I'm sorry. Updates the TTL. Okay. Get bulk gets multiple values, and get s gets a value which is the cache value, which is used for concurrency. Okay. We'll take a look at that in a second. There are other operations as well. You might think, what's the big deal? Not too many operations. They're pretty straightforward. But like I said, many of our customers are able to get by with just these operations. Yeah, append, increment, not really applicable to JSON, right? If you look at this is not really applicable to JSON. But there may be some fields where it makes sense. Increment, decrement definitely with integers and longs, right? Append and prepend really more for like binary kind of data. Doesn't quite work with JSON. Then replace and touch. Okay. Any questions on these operations? No, pretty straightforward.
Does the replace carry the cast?
Does the replace? Yes. So it changes the cast. Yeah, it does change the cast. So whenever you update the,
Does it take the previous cast?
So if you read it a minute ago, you bring it back in, so it goes, wait, that's a different one.
Correct. So what you're saying is, can I specify the value of cache when I do the replace, right? And we'll take a look. Yeah. I believe it doesn't. Okay. The way to do it is with the set. Okay. Set does really both the add and the replace. Okay. Because all that you do is, you want to check. If it's not there, then you do the, that's the difference, right? So if it's there, then you can use the same key and do the same. Okay.
So replace one rewrite.
Okay. Moving on. One of the things that gets a lot of people who are new to Couchbase is that most of these operations are asynchronous in nature. Okay. Including the get itself, which has an asynchronous version of it called the async get. And what is the idea behind making all this asynchronous? The idea is, fire as many operations as you want, and then only when you really need to check if it really happened, then you call the get, which blocks on the, on the particular operation. Okay? So you can do whatever you want in the meantime, and then you do a get, and you're pretty much ready to go. Okay? So you can do a set. Set is also asynchronous, remember, right? So you can do set, right? And then look at the get later. Or if you want to turn a set into a synchronous set, then what you do is you just do a dot get on the return value, and it turns into a blocking set, if you will. Okay? And we'll take a look at this. By default, they return a future object, which means you can cancel that operation, you can check the status, anything you can do with the future object, you can do it. Okay? I don't need to talk to you guys about this, what a synchronous and asynchronous is. But here's an example of a asynchronous set. Okay? Like I said, everything is asynchronous, right? So what I'm doing is I'm getting a future object. Okay, I'm specifying the key, I'm specifying the TTL, and I'm specifying the value. Okay? And then what I do is I do something completely unrelated to this particular value or to the set. Okay? And then at some point I come back and look at the value. Okay? So now when I do the get, I am really blocking. Okay? Is that straightforward?
So if there's replication going on, the server replicates, I make one call here,
Yes.
and then I'm not going to get my future until the server has finished its replication, got its answer from the other replicated servers, then it responds to me.
Yeah, so the answer is it's complicated. Okay. But what you can do is we are specifying the API called the observe. Okay. So you can observe whether it replicated, as many number of times as you wanted. Okay. So what happens with the typical set in this particular case is that it tells you that essentially it did one copy of that. Okay. The replicas, I have no idea what's going to happen, right? That's what it's telling you, right? If you really want to be sure that even the replicas happened, okay, then what you have to do is use the observe command and wait for the replicas also to complete, okay? But it's only a matter of, of time when those replicas are going to get pushed out, okay? So that's, you don't really worry about it, okay? But if your application demands that you have to wait for the replicas, you can do that as well, okay? It's a little bit more complicated.
So if your client crashes
Yes.
after that, did you get through everything else with it?
Yeah, that's, you will get three because again, the server propagates, right?
The other thing was, you said something about key and the value. Keys get replicated, the value.
Well, no, these are values both get, yeah, I have to, right? Yeah. Any other questions? Okay. So, just by looking at the set, it kind of looks like it's asynchronous, but it's not, it's asynchronous in nature, okay? And like I said, even a get can be asynchronous, which kind of is a little bit boggling. So what you do is, I can find as many gets as I want, and only when I really, really want to get, then I can do a blocking get, okay? Which is basically dot get, and that will block until the operation system, okay? Yeah.
Is there an API to get a callback instead of getting
Is it a good point?
to get a callback to the block?
Callback, there's no callback. Yeah. Unfortunately, you have to use the future with it. Yeah. So this leads to the next, example of CAS using pessimistic and optimistic concurrency. Okay, so the first one is referred to as the optimistic concurrency, where you let collisions happen, and when you get a CAS mismatch, essentially what happens is when I fire, when I set the value, I specify a CAS and say only when the CAS matches, update the value, right? If the CAS has been changed in the meantime, then I'm going to get a CAS mismatch, and it's really up to the application program to deal with it. So that's the optimistic concurrency control, because you say collisions are bound to happen, okay, and let's deal with it when it happens. It doesn't necessarily mean that it's a CAS mismatch is necessarily a bad thing, right? Because what could happen is, let's say there are two users updating the same page or something at the same time. What you may want to do when you get a CAS mismatch is really merge those two values, right? I mean, that's certainly possible, right? Or you might say, well, I might take the last update and just use it, really up to the application. So rather than, going to the pessimistic concurrency control, it says I'm going to lock on the entire word until I'm done with this, right? Which is typically what a lot of relational databases do, right? They kind of lock that entire row, and until it's released, it's not available for the rest of the world, right? But here you let it happen, and then you can read it, okay? And if you get a CAS mismatch, then you do something appropriate, okay? So this is a very simple using the CAS. So the client gets a key and checksum, updates using the key and checksum. If checksum doesn't match, meaning you get a CAS mismatch, then your update failed, and it's really up to you to deal with it in the appropriate time. Yes?
Okay, so the hard problem is when the system has been partitioned and both halves are still up. Does it handle that?
Yeah, but these are two entirely different systems.
Say I've got a Couchbase system with 2 nodes, and I've told it to replicate 2 nodes.
Yes.
Okay, so each system has all the data,
Yes.
and then the connection between them goes down. Can I still use either one of them?
So one, yes, you can, yeah.
So I can write to either one of them. And I can write the same key with different values.
No. So a client, a server being down is a, yes, I'll give you yes.
Either one of them is down.
Yeah.
They just can't talk to each other.
That's still one
I understand. What you're trying to do is, let's say I have 2 clients running, right? And somehow you manipulate the network to think one of the client thinks that there is only one part that is working, and the other client thinks the other part is working, right?
And the servers can't talk to each other either.
Right. So what typically will happen with the client library here, in this particular case, is like I said before, the same thing. It's not going to be available. If you want to write to that particular key, it's going to time out, okay? And then if you reach a number of timeouts, at that point, it's going to assume that the server is down, and it's going to try and write to a different server, okay?
So it will only write to the. Well, okay. So each one will run out on the other server, and then it will write to its own server.
Right. But here you're talking about the replica, right? You're propagating the replicas, and that's where we can talk about that later. Okay, let's move in the interest of time. Okay, because I'm sure there are some edge cases there that I need to discuss in a little bit more detail. But let's talk about the cache. Very simple example here. Okay, so what I'm doing here is I get the cache value for a particular key. Okay, and then I randomly sleep for 1 to 1000 milliseconds, okay, or 0 to 1000 milliseconds, okay? So which is kind of simulating a random workload, okay? And then what I do is I wake up and do a set based on the previous cache value, okay? So I woke up after 0 to 1000 milliseconds, right? And then what I do is I do an async cache, which essentially sets the particular value, okay? So that's what you would use in this particular case. So I'm using the previous cache value that I got, and I'm just setting some value. I mean, in this case, I don't really care. I'm just setting some random long value. Okay, does that make sense? Okay, and then I wait for the cache response. I do the get, which is a blocking get here. Okay, and if it's equal to, if everything is okay, then my set succeeds, right? Otherwise, my set failed. Okay. So yeah. Before I get to you, let me finish up this program. So when I run this, when I run it as one client, everything is running fine. Set succeeds, because I'm going in the loop, and there is no contention for that particular resource, so everything works just fine, right? But the moment I fire up another client, then I get into cache mismatch issues, and really depending on who grabbed the cache first, one of them succeeds, the other one fails. If one succeeds, the first one succeeds, the other one fails. If the second one succeeds, the first one will fail, and so on. Okay? And we'll see a demo of this in a little bit. Okay? So that's a simple cache example. Okay? So before I go to doc design, I think I need to go into some demos here. Okay? That's probably the easiest way. Eclipse. Okay? How many of you use NetBeans? NetBeans. No? Maybe? Oh, okay, thank you. Really feel sad when nobody uses it, but I realize that's the way. Okay. So if you want to use Eclipse and run it, very straightforward. Here's a Hello Couchbase project. Okay, all that I do is.
I don't think you can see.
I'm sorry. Thank you. Okay, so now basically what I do is I import, okay, and import an existing maven project, okay, and then I go to the appropriate directory, okay, and in this particular case I go to Wax, hands-on labs, and you can find the, if I just pointed at the top directory, you can find the com, and I'm finished, okay. So I have my Hello Couchbase here, okay? And what we do is we just look at the form file. Okay, here's my form file. And you'll see here, basically I'm getting it from Couchbase.com, maven2. Okay, and it has a bunch of dependencies, really dependent on the Couchbase client. And the Couchbase client itself is dependent on a whole bunch of other jar files, and all that is done using the beauty or ugliness of Maven. Okay. So I don't need to worry about that. Did you have a question that I completely skipped over? Yeah.
Oh yeah. So I was curious, when you fire off the async set,
Yeah.
when does it get propagated to the server? Is it when you do the blocking get right at the point, or just kind of at the random point?
Random, yeah. Blocking get is basically to be assured that it's already done. Okay. And even at that point, you are not sure whether it's persisted in memory or persisted to the disk. Okay. You're guaranteed that it's persisted somewhere. Okay. And you don't, when if you're really keen on, all you persisted to disk and persisted to, the replicas, then you have to use the observe command. Okay. But let me move on in the interest of time here. Okay. So this is the form file, and I know we have a hard stop at 9 o'clock, so I want to go till 9. So what I'm doing here is I'm using something precedence.json, which is right here. Let's take a look at the precedence.json. Okay, so essentially it has precedency for each of those. Okay, the name and so on and so forth. Okay. So I'll give out a T-shirt for somebody who can tell me how many presidents came from the beautiful state of Washington. 0. 0? Really? I'm sorry, I didn't mean to. I thought that would be a few. Okay, so that was just a guess, or are you sure?
It was just a guess, but
No, okay,
I'm pretty sure.
It didn't exist in the first half.
We'll run the view and if it is really 0, you get something. If it's not 0, you get a 0. Okay? Is that okay? All right. So there's presidency and there's a whole bunch of information associated with this. Okay? So I go to my app, and all that I'm doing is I'm using the JSON library. Okay, how many of you use JSON? Very easy to use, right? And essentially what I'm doing is I'm defining the president class, and then what I do is I go through each of those entries, and you notice here I'm specifying the Couchbase client, I'm using the local host, I'm specifying pools, I'm using default as the bucket. I go through each of those entries and I press. And I'm pretty much okay. Very straightforward to run this, right? So what I'm going to do is I'm going to run this. Okay. So it gives a bunch of information of, it opens some connections, and then it persisted, all the things, okay? And it persisted it for how many seconds? Do you say how many seconds? 0. If you mean, when you say 0, it means that. So, pretty straightforward example. Okay, now I'll switch back to something I'm more familiar with, which is my NetBeans. Okay, fire up NetBeans. But you don't really have to use NetBeans. You don't really have to do eclipse. You can do it from your command line as well.
Sorry, can you explain why there was a 3-second pause at the end of the shutdown?
Yeah. So basically you're waiting up for the queues to complete. That's really that's the recommended practice.
Well, if it took 4 seconds, something bad had happened?
No, anything more than that is fine. 3 seconds is kind of the minimum. That's what we recommend. So, if it's less than 3, then something bad might happen. Okay.
Is there a more?
It's basically about cleaning up the NIO sockets and so on. Okay. Yeah. XLR beta, usually you're fine without that. Again, some of these are legacy based. Okay, so let me run this file. Okay, so remember this example? This uses gas, okay? And I'm running this, and my sets are going to succeed for as long as I'm running this, okay? So the moment I start running, let's look at the consumer Java file, and it's exactly the same thing. Instead of sleeping for, 5 seconds, 1 second is sleeping for 5 seconds. Okay, and notice I succeeded. Okay, and now I run this. Run this again. Okay, so I have another instance of the same, right? Now there is going to be, optimistic concurrency control, and you'll see here that these sets succeeded, and I'm sure these 2 sets failed. Okay, and really randomly, hopefully at some point this will come back and succeed. At some point, come on. Oh, there you go. Okay, so when this succeeds, now this is going to fail. It's really entirely up to how well it prepared the algorithm. Okay, so I did a very simple example, very contrived example where I didn't really do anything with it. I just showed the problem of concurrency. Okay, what you deal with it. that's really your problem. You will go and fix it. Okay, as a teacher, the prerogative is to take the easy example and show you the problem. And I like to deal with the more complex problems. So moving on. I still have some.
What about the president's thing?
Yeah.
What's the teacher?
I want to be sure of the teacher. Okay. So let's take a break there, and what I do is I report the president. Okay. So what I'm going to do is I'm going to go to localhost. Okay, so that's the admin console. Okay, and you should see at least 44 keys in there. Okay, maybe more than that. Okay, so if you look at the data bucket, I have some 130. I have all kinds of things in there. So that's not very good. Okay, but essentially it's definitely more than 44. And I define what is a view. I haven't got to it yet. Okay, but bear with me. I'll talk about that. And essentially there is a president, and it basically emits state and date. So it emits it by state and it groups it by state and all that. Okay? So what I do is I run this, and this should tell you whether you want a t-shirt or not. I know you're very keen on that. This is, different.
They don't use 10.
What type is president, not the home stage? Okay. Home state, right here, yeah. And then what I'm doing is I'm just doing a count. Oh, there you go. There's the value. Okay, yeah, because that's something different, yeah. So Arkansas is 1, Massachusetts is whatever. Okay, and Washington, it's not even part of the system, so it's not. Okay, so you are right, and you got it.
But that doesn't have 44.
That's not 44, so where's the rest of them?
Yeah, 44, right? Yeah.
You seem to be missing Texas, for example.
Yeah. We knew about one from Texas, didn't we?
Okay, let me do the full consolidation. There's tab. I missed a tab. Yeah, there's so no Washington.
W, next page.
Wow, lots of Washingtons. Holy cow.
So nothing in Washington at all.
No.
Okay. So New Hampshire has 1, New York has 7, Pennsylvania has 1, Tennessee has 3, Texas has 4, Virginia has 5, and so on. So you do get it.
Can you show me what was the query you entered?
Yeah, I talked about that. Okay. Yeah. Unfortunately, he was so keen he wanted a t-shirt. He made me jump so big. Okay. So why use JSON? Because everybody else is doing it. Okay. JavaScript is sexy. JSON is sexy, and that's why there are a number of reasons for that. Because it's very easy to kind of transmit it between different languages, different platforms, and so on. And that is why we use JSON. And also, it is pretty powerful in that you can define data types and so on. Okay. Here's a very simple clear brewery example. Okay, that we'll take a look into. Okay. It has ID, name, ABV. ABV stands for alcohol by volume. Okay, so I may want to do some fancy things by alcohol by volume because only if it has good alcohol by volume I'm interested in it. I'm interested in only the top ABV. Things like that. And then it's associated with the brewery by, beers are made in breweries and breweries make beer. Okay, as simple as that. Okay? And this is how my document looks. Okay, there's a primary key, there's a type information, okay, and then there is a foreign key also, right, which is really the brewery ID. Okay, and the beauty of JSON is that you can add this as an afterthought. Okay, if you want to. Okay, so I showed an example of where what I did was, I did the same JSON example, right? I go back to my NetBeans, okay, and the same residence example. Let's see if we can find this. Okay, this is from the files and residents and look at residents at JSON. Okay, and what I did was I added a notable field for for some of them. For Barack Obama I added healthcare. For Bill Clinton obviously I added Monica. Okay? And for George W. Bush I added Nina. Okay. So you can kind of adapt your data, and what I'm going to do is I can add a Twitter handle to Obama. Yes. Right. Right. So I go back to my projects, okay, and look at my president at Java, okay, and I'll add a Twitter, right? And the neat thing is, you can evolve your schema as you kind of go. And now when I process this, okay, hopefully it's going to add the Twitter handle only for. Okay, don't worry about that. That's I'm putting some debug statements in there when I'm debugging something. So you should be able to see this having a Twitter handle. Okay, and then what you can do is you can go through each of those rows and only pull out the ones that have a Twitter handle. If Twitter is not equal to null, okay, then you can pull it out and say these are all the the Twitter handles for each of this. Okay, so kind of your application evolves with the real world rather than you're force fitting your application into columns and so on, and having to deal with the expensive order table operations. Okay. So the last part that I want to talk about is the views, which is a really cool feature. Okay. Essentially, this is an answer for some of the use cases which don't use the key value. Most of the 95, 97, 99% of your use cases might be key value based, right? But those 1% might use may not be key value based. Example, coffee shops and yeah, right? How do you deal with this? Is by using views. And how did I deal with the example where I wanted to find how many presidents from different states? Is using views. I define a view over the data and kind of iterate through that. Okay. So views are a way in which you can define secondary indexes. You can do anything you want with views. You can slice and dice your data in whatever form. Okay.
Okay, so that earlier query was an aggregation view, basically.
Yes. Repeat your question, sorry.
But I asked you earlier what was the query. That was basically an aggregation.
It was an aggregation function, yeah, and I'll come to that in a moment. Yeah. So essentially, I defined a view and then an aggregation function, which is really 100-bar count. Okay, count basically counts the number of residents. There are other. There is count. There is view, which is blank. Count, sum, and stats. Okay, so there are some aggregation functions that are predefined, but you can add your own aggregation functions as well. Views are completely optimized. Okay, they are also completely distributed, which means the indexes are stored on each of these different nodes. There is a collation that happens, and really don't ask me the question right now because I'm not prepared to answer where the collation happens and all that. Okay, but let's not worry about that. Essentially, the indexes are stored in a distributed fashion, and they all come together when you access the view. The indexes are not updated until the view needs to be accessed, which means there may be a penalty sometimes, depending on how frequently your data gets changed and so on. But there are ways in which you can get around this by saying I don't want the latest view, I am okay with a stale view, in which case it's not going to update the index when you access the view. It might get you a slightly older data, okay? But if you're able to live with it, that's fine. Okay, so there are different ways you can optimize this. If you put it in different buckets, there are ways in optimizing it. But that's an entire, different topic that I don't want to, talk too much about. But just to tell you that it's possible to optimize it. Did you have a question? Or? No.
Could you put the query handle on the screen?
Yeah. I can do that. I can do the presentation. because there's so much interest, let me go straight there. Okay. So the view, okay, and we'll look at what this is in a second. Okay, let's look at this beers by ABV. Okay. So essentially, it's a map-reduce code which is written in JavaScript. Basically, what I'm saying is, if doc type is beer, then what I'm doing is emitting doc.abv in the doc itself. Okay, this is probably not a good example of doing. You don't really want to, emit the doc also with it. You just emit null, and then you can get the doc associated with that particular document, through Java. But in this particular case, it's fine. Okay. So when I run this, what do you expect to happen? Basically you see that you have the ID, right, of the beer, and then the entire document itself. Okay. So that was one example, but let me go back to the one you were interested in, which is really the count, right? So what I'm doing here is I'm doing exactly the same thing, okay? But I'm also using a reduce function called count. Okay? So now what's going to happen is it's going to emit ABV and 1 for each of those. It's going to consolidate based on that, and then it's going to count based on the ABV. Okay, so let's look at this result, and this can, essentially what it did was it consolidated all of them into the count. Okay, because I think what I did was, maybe I did a group by. .abv count. Okay, so let's see if I can do that. If that doesn't work, I have a way of getting it on this. Okay, so essentially, now what it's doing is it's showing by count. Okay, so there are 2 beers with alcohol by volume is equal to 4. Okay, one beer 4.5, and I think quite a few, or at least 2 with 10. Okay. So you see that? Yeah.
What you just did was separate from the view.
This is the view.
So scroll down a little bit. You've got some stuff there's some blue text.
Yeah. So what I can do is I can filter the results. Okay. And what I did was I grouped based on the ABV. Okay. So if I don't do the group on ABV, it's just going to emit, and counts all of the beers. So there are totally about 38 values in this. Okay. I mean, you can play around with this. It might seem a little complicated initially, but it's not that complicated. And if I go back to the view that we looked at before, that should be pretty straightforward here. So here's my president, right? And essentially what I'm doing here is I'm looking at, is it of type president, right? And then what I do is I emit home state and I emit the name. Okay?
So the type field here, you're just using a field of that name by convention in your views.
Yes.
Not
Yes.
built in.
Not just in the view. It's in the persist. When I'm persisting the JSON document with the type information.
Right, but if I wanted to use a field called foo, I could do all the same stuff and call it something else.
Absolutely. Yeah. Not a problem. As long as you have it.
The ID field, is that a special name?
Yes, there is an ID field, and
That's
I think
built
there's
in
a
the
reference.
That name ID is special to Couchbase.
I mean, you don't really. It's an internal name. It adds another underbar ID. Okay, but in this particular case, let's take a look at this. There is an underbar ID, right? That Couchbase adds.
Okay.
Okay, so you don't need to worry about this. I have my own ID as well. Actually, let's do this. Let's click the random document, and if you see a brewing company, it becomes pretty obvious. Okay, so I have not only an underbar ID, I also have an ID.
Okay.
Okay, so it's really up to me. No, I could have called it anything I want.
Those don't have to be the same. So the underbar
Yeah.
ID is when all those slides where I use the word key, the underbar ID is the key.
Yes.
The key value stuff.
Yes.
That's the key.
Yes.
Okay.
So actually, let's do this. Then I think it'll drive home the point. So I'm writing the peer here, right? So I'm writing the peer, and exactly same thing, JSON document. And what I'm doing here is set entry.id 0.JSON. Okay? It could have been anything really. It could have been .dm. That's fine too, right? As long as it's unique, you're fine. I could call it anything. Couchbase also uses, has some, like underbar ID. That's really more of a CouchDB thing, which is kind of crept into Couchbase as well. Okay. So I know we jumped around a little bit, but let me try to summarize this, okay, and finish up. But I think it was useful. I mean, did you get your question answered? Yeah. Okay. So I take from the next slide.
And by the way, you can do queries like that from the API, right?
Yes, yes. And I don't think I showed that to you. Actually, let's do that right away.
That would be a REST call at that point?
No. Oh, I see. So your question was, can I create this viewer query programmatically, right?
Yeah, from my job.
So yes, you can. Then you're absolutely right, and you get one more T-shirt. Did I give you a T-shirt already? Or no, you get a T-shirt. Yes, you can do that by REST. You can specify, and we do that all the time. Especially when we're testing some of the queries and so on. Yeah. Yes. Question.
So if you have a web interface or users are entering arbitrary queries, you wouldn't be creating, or would you be creating views for each query every user?
Yeah, see, essentially you have to create a view to have a secondary index, okay? Only if you create a view, you will have a secondary index, okay? And you're right, I mean, if you just create a random secondary index, it will create random views, If you change your view, it's going to re-index the whole thing, because, things could change completely, right? So there are lots of things that you need to be concerned about when you're doing, when you're dealing with views. But I still think it's a very, very powerful mechanism. And this actually was invented by Damien Katz, who was the person responsible for CouchDB. And I think it's a pretty cool concept. Okay? It's based on what is referred to as the incremental map reduce, meaning that it's going to be done only if necessary, and it's completely optimized. And we're still looking at ways in which we can optimize this even further. Okay? Because as you can imagine, if you have a billion values, okay, and getting one value, key value pair is constant time, that's fine, right? But if you're trying to look across those billion values and get a view, it might take a little bit too long, right? So you need to really optimize this, optimize the heck out of it as much as you can. Okay. So we looked at all this. So here's an example of how a map reduce works. Some of you might already know how map reduce works, but look at this particular thing. Basically, what I'm saying is, if doc.type is brewery, and there is a field called doc.province, okay, then I emit the doc.province and the doc.name, okay. So province name is the key value pair that's going to be emitted, okay. So it's going to be sorted on the key comma value is how it's going to be emitted. So think of it something like this, conceptually. Okay, the key is Connecticut, value is something, key is Connecticut, value is something, key is Massachusetts, New York, Washington in the middle, Vermont, and so on. Okay? So that's kind of how it looks. And then what happens is, if you write a reduce function like a count or something like that, right? Then basically what happens is, key values return the values.len. So in other words, for Connecticut, it's going to return 2. For Massachusetts, it's going to return to 1 or whatever, and so on. Okay? So this is kind of conceptually how the map reduce works. So for Connecticut, it's value 2, Massachusetts, the value is 1, for New York, the value is 1, for Vermont, the value is 1. Okay? That's kind of how the map reduce works. Okay? How do I use it in Java? I define my view, I define a new query, I can say set reduce, I can set include docs, which basically lets me get the entire doc if I want. And there is a property called scale property, which I can use. Okay. Then I provide the get view. Okay, and then I specify what is referred to as a design document and the view name. Okay. So if I'm using the press name, right, I would do something very similar. Okay, so let me go straight to the code because I think I'm definitely running out of time. Okay, so I think I have something in my precedence package, so we'll take a look at that. Alright, so here's my precedent view. Okay, all that I'm doing here is I'm looking at the get view, precedent and precedent. Okay, if the view is null, okay, then I flag it. I create a new query. I set reduce to true. Okay, I could set it to false, in which case it's going to work a little bit differently. Okay, and then I specify the view and the query, and then what it does is it provides me the iterator where I can go through each of the rows and do whatever I want with it. And what I'm doing here is I'm getting the key and I'm getting the value by just getting the whole document. Okay, let me run this and then I'll answer the questions. Okay, so let's run this and see what happens. Okay, exactly the same thing as before, right? So, key is California and the document is 2. Okay, so basically the value is 2. So there are 2 presidents from California. I believe it's Reagan and who's the second? Nixon. Okay, so and so. Sorry. Yeah, US.
So can you create views programmatically?
Yes.
Create views in the admin console.
Usually created from the admin console, but anything you can do on the admin console, you can do it through REST. So you have if you want to create it programmatically, you use the REST interface and you create it. And we do that all the time. We have examples. You can do that. But I think usually in a production shop, you would put it under version control. You would control it, fairly carefully, especially if you're dealing with billions of records. Okay.
I'm confused. So
yes.
the map reduce operator, where is it happening? Is it happening in the Java code, or is it happening in the Couchbase?
No. So the map reduce happens. The map reduce happens on the server. Okay. In Java, what I'm doing is I'm accessing the view. When I'm accessing the view, I'm given access to the indices that have already been created there. Okay.
I mean, the Couchbase understands Java. Or how is that the map reduce?
No, I think it's a good question. And basically, what you're saying is, how did I create the view, right?
Yeah.
And what I did was I went to the console. Okay. Unfortunately, I kind of went a little fast on this part, right? So if I'm doing BS by ABB, right, what I'm doing is I'm creating this on the console, on the server side. Okay. So there is a tab called views, okay, and that allows me to create views. Okay. I can show some example of this. Okay, how you can create a view and so on. Okay.
So connecting with the previous question,
yes.
How can I create a view on the fly programmatically?
Programmatically. So anything you can do through the admin console, you can do it through REST. Okay. So what you have to do is I haven't shown that, but there are some examples I can show.
And you can implement a language to the file.
You have to send a REST query, and you're going to get a REST response.
Basically, you would send that text to an API.
Exactly.
You use Java to send a JavaScript straight to
No, I'm getting that. I'm a little bit confused.
It is, because there are just too many things available here. Okay. Yeah.
Can I go back to the consistency question? Because I don't think we haven't quite got to the bottom of that. I'm talking about walking through here. So you had the cap theorem way back, right?
Yeah.
So we know we're giving up on consistency. So there's going to be inconsistency, and that's the point, right? And there's going to be data that's inconsistent because you're going to get the other two.
No, we are more of a, like I said, CP system, right? We want to be consistent.
Oh, so you're getting up on availability?
Right. Yeah, we are giving up on that. Yeah.
So you're guaranteeing consistency then?
Correct.
So
But with respect to views, it becomes a little tricky. Okay. You can, if you set the scale property to true, then you may get inconsistent, not inconsistent, but not necessarily up to date data. Okay. So at that point it becomes a little different.
Right.
Okay?
Yes. Can you repeat that? That's kind of fundamental. You're saying that Couchbase inherently does consistency work can be configured to favor consistency.
Yes.
That's
Sorry, what did you do?
You're saying
It is a
Couchbase
CP.
is inherently about CP.
It is a CP-based system, which means that, yes. It's not, so what it means is, if a particular node is not available for a certain amount of time, you will not be able to write the data. There may be some non-NoSQL databases which will let you write and maybe persist it eventually, right?
So you like this MongoDB that it will
You
write
can configure it
nodes,
differently, yeah.
and then it will asynchronously populate to the other nodes for failover. So now in the case of CouchDB, it's not doing that.
No, it does. It does asynchronously, okay? But what happens is, if you are trying to write a particular key that maps to a particular server that's down at that particular moment, okay, then you will not be able to write that key until either the node is declared as dead or that node comes back and you are able to write it. Okay? So that's what the availability problem is.
Okay, yeah, because the other nodes are just as for failover.
Exactly.
Well, it's not that when it's dead, right? It's dead, and another service brought up, they just replicate across and then it's all right. It's not. It can't.
No, when it's declared as dead, then what you can do is you can go and write to another node, right?
A new one becomes the lead for that key.
Right, exactly. Yeah.
And then how do you know what the last value was if you lost it?
You lost the value, right. There are ways. No, but again, yeah, it's really up to client. What you can do is you can say, after a particular timeout, if you don't want to write that value, you can get back and say, I can't write this value for now, and back off and do it again, okay? Or you can deal with it in different ways, okay? Yeah, it is. There are a number of different permutations and combinations. I'm sure I've only scratched the surface, but I'm sure many of you are waiting for the helicopter drawing, right? So I'm going to randomly pick a name here. I picked Keith Bloomfield. Keith. All right. You're the lucky winner of the
Yeah, that's great. I just brought my cats to that today. We got the vaccinations. Oh, right. So we're great to bring this home and see it.
And then you had
all right.
Dave.
And for this,